The Adler-Alpica Service Combined Motorway and Railway route is one of the most complicated transportation infrastructure projects for the Sochi Winter Olympics. As part of the project, the SK Most group of companies is building the most challenging 32-kilometer-long section from the town of Akhshtir to the town of Sadok. The work had to be done in a nature conservation area, fitting in the winding and narrow Mzimta River Canyon, which already has numerous pipelines and power transmission lines and small settlements. The Mzimta is a river with a challenging hydrology, which is why the locals call it MAD. The difference in elevations within the section of the SK Most project sites is in excess of 400 meters. Neither was the geological situation easy. Tunneling had to be conducted through slanted beds of rock of different hardness, which had inclusions of large boulders and contained groundwater. All road structures were built to withstand earthquakes of 9-point seismic magnitude in the area. To build the route as straight as possible while preserving the environment, the engineers have designed 45 highway and railway bridges of a total length of over 20 kilometers and 12 tunnels that are 30 kilometers long and also more than 23 kilometers of earth-filled roadbed. A network of newly built access roads and a dozen temporary bridges over the Mzimta River were used to support the non-stop operations at the construction sites. The engineering problems in building the temporary facilities proved almost as challenging as the main construction project itself. 11 access bridges and 20 kilometers of new roads were built during the first year of operation, and 30 more kilometers of roads were upgraded. A part of these access roads and bridges will remain in permanent service to increase the resort area traffic capacity. As the construction pace grew faster, the concentration of special equipment became unprecedented for modern Russian construction sites. Speaking of 4 to 13-meter diameter tunnel boring machines alone, 6 of them were in operation at a time. Up to 30 drilling rigs were simultaneously in operation to build bridge pillars and retaining walls. Hundreds of vehicles, lifting cranes, and earth-moving machines were busy all the time. The Lovat 232 tunnel boring machine, with a 5.9-meter cutting diameter, was used for driving a service gallery for tunnel system number 1. The railway and motorway tunnels were built by mining methods using alpine miner road headers combined with blasting operations. One year after work began, the driving of the service gallery for tunnel system number 1 was completed in May 2010. Connection of the motorway tunnel and railway tunnel was completed in December of the same year. The tunnel system will be commissioned in the second quarter of 2013. Railway tunnel number 2 at the 23rd kilometer is the shortest of all the tunnels on the route. It is practically 150 meters long. The tunnel was driven by the mining method. 4 tunnel boring machines were running simultaneously to drive tunnel system number 3, which is over 4 kilometers long. The Herrenknecht 13210, which is the largest one among them, with its 13.2-meter cutting diameter, weighs over 2,000 metric tons. This machine was ordered specifically for motorway tunnel construction in Sochi. The Lovat 394 tunnel boring machine was used to drive the railway tunnel. The service and operations support gallery was built by both mining methods and using tunnel boring machines. The Lovat 243 was launched first from the southern tunnel entry, and then the Lovat 232 tunnel boring machine was relocated from tunnel system number 1, started to move from the northern entry to meet the first machine. Driving with 2 tunnel boring machines significantly reduced the tunneling time, not only in gallery driving, but also when the main tunnels were driven, since the operators had already obtained the soil data. The railway tunnel of tunnel system number 3 was driven using a combination of methods. 10.2 meter diameter Lovat 394 tunnel boring machine was moved from the southern tunnel entry, and the mining method was used for tunneling from the northern tunnel entry. This combination is used quite rarely, but it was justified by the extremely challenging geological conditions. Railway tunnel number 4 at the 36th kilometer of the route was driven by drilling and blasting. The railway tunnel of tunnel system number 5 was driven using the 10.6 meter diameter Herrenknecht 10690 tunnel boring machine. The machine was purchased specifically for the Sochi construction project. The motorway tunnel was driven by the Mitsui Miike roadheader. The tunnel was driven in weak rocks, and special methods were used to shore up the unstable soil. Jet grouting is one of the methods. The method is based on drilling 12 to 15 meter long boreholes over the face cross-section, and cement mortar is injected into the boreholes. After the mortar has set, the tunnel walls and vaults become stable and cannot collapse. The service gallery for tunnel system number 5, which is almost 3 kilometers long, was completed in 11 months using the 4.2 meter diameter Lovat 167 tunnel boring machine. The work began in June 29, and the machine exit from the northern entry was commissioned in June 2010. Railway tunnel number 6 is located higher than all other tunnels in the mountains on the route. It is situated at an altitude of 500 meters above sea level and is 430 meters long. Unlike the other tunnels, this is a double-track tunnel. The tunnel was driven by the mining method from the southern tunnel entry. The driving from the opposite entry had to be postponed because the work required preparation of the tunnel entry site and slope consolidation. The SK Moss Group of companies has built 45 bridges with a total length of about 20 kilometers in the section between the 14th and 46th kilometer marks. Most of them, which add up to 12 kilometers, are specially rated bridges, meaning they are longer than 500 meters. Over 100,000 metric tons of steel structures will be installed, and 300,000 cubic meters of concrete mix will be poured to build all the bridges on the route. Certain diversity dictated big differences in railway bridge span structure designs. A total of 8 span structure types have been developed, which differ in both dimensions and track design. The motorway bridges did not require standard modules, which is why each design was custom-made. The stay cable bridge at the 25th kilometer of the route was rated as the most challenging by experts. The bridge's total length is over 800 meters, with a 312-meter-long central span and with pylons that will be over 80 meters high. The special 20-meter high metal caps of the pylons will have the cables attached to them. This is the first stay cable bridge to be built in the south of Russia. The longest railway bridge on the route, which is over 2.5 kilometers long, was built to run parallel with the stay cable motorway bridge. The project was built within the permanent landslide area. The builders faced a challenging engineering problem of bridge protection against the forces of Mother Nature by erecting retaining walls. The work had to be done simultaneously with the construction of the railway bridge and practically sharing the construction site with the stay cable bridge project. Concrete mixing plants were deployed over the entire construction area to cover the construction project demand for concrete mix. Steel structure stowing grounds have been provided and equipped at each bridge construction site. Tunnel entry sites and freight yards have been put in place at each tunnel entry. In less than a year, a plant producing tunnel lining segments was commissioned in the Imereti lowlands. The plant, with an area of 17 hectares, produced up to 15,000 pieces of lining segments of different size every month. This plant is unexcelled in Europe so far. After the tunnel lining operations were completed, the equipment was relocated to the Tolbino production facility near Moscow, and the plant site with the production buildings will be used by the city. Bridge builders and tunneling worker camps have been put in place as close as possible to the construction sites, and they are equipped with all the necessary utilities, including water treatment plants. A constant temperature of about 25 degrees centigrade is maintained in the living quarters and production areas. A diet for company employees has been developed based on the hot subtropical climate of Sochi. The cost of providing comfortable accommodations for specialists pays back by efficient project management, on-schedule work completion, and top-level work quality. Five bridge companies, 2 specialized drilling companies, 1 road building company, and 7 tunneling companies, with a total of 12,000 employees, were directly engaged in the construction of the route to the Olympic projects. The companies, which are united under the aegis of SK Most and rely on an army of highly skilled professionals and a huge fleet of special construction machinery and motor vehicles, are capable of undertaking large-scale construction projects and deploying their structural elements in any corner of Russia and in the shortest time possible.